Hey, Walter Sorrells back with more tips for the knife maker. Today, making a Tanto point tactical blade. Hey guys, really excited today. I'm kicking off my collaboration with Pops Knife Supplies in my first Pops project of the month. Today, making a Tanto point tactical blade, cool feature, removable, replaceable handles. Now, Tanto points are one of the trickiest things to grind in knife making, but there are a few simple techniques that you can use to make the process a little easier. Stick around for some tips and tricks that'll help you master the dreaded Tanto point. Today I'll be using some 8670 steel and some really interesting micarta scale material. More on that later. Finally, a bunch of 832 screws and these little dudes right here, 1/4 inch threaded inserts. We'll start by profiling the knife. A few weeks ago, Andy at Pops asked me about why I didn't use patterns for drawing my blades in my videos. Usually I just draw them with a pencil or something like that. So today I'll be demonstrating the technique he was alluding to. The reason, incidentally, is that when I started Tactics Armory some years ago, I did use this technique of having a pattern, but I haven't done it in years. Anyway, the idea is that anytime you're making more than one copy of a knife, you can easily grind a pattern from a thin piece of micarta, a plastic like Delrin, or even a piece of aluminum. Then you just drill a hole in it and hang it on the wall. Every time you need that knife, pull it down from the wall, use a scribe and maybe some layout fluid to mark the pattern, and then grind it out from there. Before heading to the grinder though, I'll take a detour and drill the holes for the handle scales. I'll be drilling 1/4 inch holes which will mate with these little threaded inserts I showed you earlier. Put the holes wherever you want. Now I probably didn't need to tell you, but this video is sponsored by Pops Knife Supplies. Pops has everything you need for knife making, steel for both stock removal guys and hammer bangers, a huge supply of handle materials including all kinds of wood, bone, horn, antler, micarta material including Pops specialty vintage micarta, all sorts of abrasives, belts, sandpaper, specialty abrasives, fasteners, tools, you name it. But here's the secret sauce. Figuring out what kind of steel or material to buy to make a particular kind of knife can really be confusing, even to me after all these years I've been doing this. All 4 partners at Pops are skilled knife makers, so if you want to get a little guidance, they're pro knife makers on hand to help you figure out exactly what you need. Then it's off to the grinder to profile the knife. Nothing really tricky here. I'm using VSM ceramic belts from Pops. I'm a big fan of ceramic. All rough grinding benefits from using ceramic belts. These are very aggressive belts that theoretically maintain the sharpness of the abrasive grains as they break down. Now, I can't verify the science, but I can tell you these things last. Anyway, profile done. Unfortunately, that is about it for the easy part of the grinding. The good news though is I'm going to show you some tricks for what, just being honest, is some fairly tricky grinding to make the bevels on a Tanto point knife. As usual, my first move is to scribe a couple of tiny lines down the blade as reference points to make sure the bevels are symmetrical side to side. I'll also apply layout fluid and use a pair of El Cheapo calipers to scribe lines for where I want the grind to go. There are 2 trouble spots in grinding these things. The first is that maintaining a dead straight bevel grind along the main part of the blade is wicked hard, as they say in Boston. Grinding a totally dead straight bevel on a straight knife is about 10 times harder than grinding a curved bevel. I don't know why that is, but it just is. The other problem is the tip, which can be a bear to get right. We'll take these on one by one. Now, a lot of people assume that using a jig is the big trick to getting good grind lines. Unfortunately, maybe not. Still, let's give it a whirl. I'm setting a 6-degree angle on my jig, By the way, I've got a video on how to make one of these dead simple jigs. Cheap, easy to make, pretty cool little things. So now I'll start grinding my main bevel. Gotta tell you, I've been doing this for 20 years and I'm struggling to keep a nice straight line across a 4 or 5 inch surface. Jigs have a way of catching or kind of dragging on the table, and all it takes is just a tiny variation in pressure or angle to bite in and cause a wiggle in your line. But if you're patient, you'll get there. First tip, don't try to go too fast. If you have a variable speed motor, back off the speed. Also, back off on your pressure a little bit. Second point, don't panic if you're not perfect when you're hogging off material with a heavy grit belt like this 36 grit ceramic. Sometimes it's easier to fix things with medium grit belts. But this leads me to my main trick. Depending on the type of belt you're using, you may be saddled with 2-inch bump or a little sag next to the plunge line no matter what you do. If the belt's cupped or uneven or whatever, it's just very, very hard to get it right. So what I do is angle the blade just the tiniest bit, so I'm barely making contact with the corner of the belt. Then I feather it in and just gently remove a tiny bit of material on the low spot. That'll creep that section of bevel back up until you've got a nice straight grind line. Here we go. Now, believe it or not, I'm actually more comfortable freehanding this. It takes more skill, I guess, to maintain really clean angles, but you have so much more control freehand that I feel like I grind cleaner on straight grinds when I go freehand. A couple pointers. Again, I'm using the same trick I did with the jig. When things aren't dead straight, when you have a little wobble or sag in that grind line, just use that corner to very gently ease the line straight. Generally, as I move up to higher grits, I can take a few final passes flat to the platen and make the grind look nice and clean. In this case, I'll go 36 grit and then 120 grit ceramic. Then I'll switch over to 3M Trizac belts. I'll go 300 micron and then follow that with 160 micron. I love these Gator Grit Trizacs as a finishing belt. Predictable, clean, great for getting nice, crisp, straight grinds. Okay, so once we got that squared away, the next tricky part, the tip. You'll notice that I completely ground the main bevel first. I really got it as close to perfect as I can at this point. The reason for this is that the unsupported final part of the grind is really hard to get right. If you grind the tip at the beginning, it's super easy to screw up that little intersection between these two lines. You want a nice crisp triangle there, but if you wait until the main bevel is good, you can screw this part up and then just grind it away. So if you wait until 90% of the main bevel is good, you can screw up just a little tiny bit on the end, and that's not a problem because you can just grind it away and now everything's perfect. So tip number one for the tip is to do what we're doing here. Bevel first, tip second. Now I've got a variable angle table for my Ameribraid grinder, and we're going to use that for the second trick here. Tip number two is basically just to use that table as a sort of jig. I'll set the angle exactly the same as my bevel, 6 degrees. Now, and this is key, with the cutting edge running perpendicular to the belt, I'll just sneak the point up there slowly until it gets to be a clean chisel grind. I don't really have to do anything, it just does it for me. Which reminds me, the so-called Tanto point has nothing whatsoever to do with the geometry of Japanese swords and nothing to do with the Japanese blade known as a Tanto. As I understand, it was just a marketing gimmick name sort of thing given to the chisel type grind by the guys at Spyderco Knives when they came out with a tip on one of their knives quite a few years ago. And here we go, nice clean angle here at the tip. If you've gotten this done, believe it or not, the hard part of making this knife's over. Okay, so let's go ahead and heat treat the knife. So Pops considers 8670 to be sort of their house steel. They recommend it to novices because it's pretty forgiving, pretty easy to heat treat. It's really a good steel for beginners. Pops 8670 is American made and it comes from the mill ready to heat treat with no need for normalization or any other preliminary heat treating prior to quenching. In order to minimize scale, I'll give it a couple of swipes with no scale. This will both make it easier to clean up after the heat treat and decrease any possibility of decarburization, which might soften the surface of the steel. I'll heat the blade to 1500 Fahrenheit, soak it at temp for 15 minutes, then quench it into Parks 50, a fast quenching oil, though it should be fine with canola or something similar. Then, tempering at 2 cycles of 400 degrees to increase toughness. A lot of beginning knife makers are unclear about the difference between hardening and tempering. Hardening converts the steel to martensite, which is the hardest form of steel. Tempering then reduces brittleness so that the blade won't break during impact. You can't have one without the other. A quick trip to the grinder. And everything looks nice and clean. Now let's talk about the other fun thing in this project, removable handle scales. I'll actually be making 2 sets of scales for this project. For the handle scales, we'll be using a couple pieces of cross-cut micarta. Again, this is kind of a Pops specialty. As I showed in our Pops tour video last month, they carry these mammoth thick pieces of micarta that they cut across the grain. Now normally with micarta you start with a thin piece like this and you just cut a rectangle out so that any grinding you do is sort of with the grain. But they cut the opposite way, which creates a really unique look that we'll see later. Otherwise, it works and handles just like normal micarta. So what we're trying to accomplish here, 2 things. First, we want to drill a hole for the fastener, the screw, to go through. Second, we want to relieve the bottom and create a little pocket that mates with the little insert that the handle screws will fasten onto, because that insert is thicker than the tang of the knife. And then on the top side, you also need to countersink a hole that the head of the screw can nestle down into so it doesn't bite into your hand. 2 challenges. You need the various holes to be perfectly concentric or nothing will line up right, and they have to mate exactly with the holes in the tang. In order to do that, I drilled out 1 insert so that I could use it as a guide for drilling the screw holes. So I put the insert in and then drill through that hole in the center. Then I'll drill a pocket on the back side, and you can either align this on your drill press and use a spade bit or a purpose-made step drill, even an end mill. As long as you get it centered right, anything will work. This centers the hole for the screw to go through. Then put a second insert in the first hole for alignment so that we know it's in exactly the right place. Then drill the second hole. That's the tricky part. Then I'll drill a pocket on the back side for the fastener, and you can either align this on your drill press and use a spade bit or a purpose-made step drill, even an end mill. As long as you get it centered right, anything will work. In this case, I've drilled the pocket pretty deep because I'll be grinding off a bunch of material, thinning them out substantially. I've chosen these really short screws so that I don't have super thick, goofy handles like certain production knives, which shall go nameless. The brown scales will use a flathead screw, so they'll be countersunk with a cone-shaped countersink. FYI, countersinks come in 82 degree and 90 degree sizes. Most flathead machine screws use the 82 degree, so make sure you got the right size countersink. So once all of this is done, I'll mark out the profiles of the handle scales and cut them roughly to shape on my bandsaw. You can just grind them, but this saves you about ½ an inch of micarta dust in your shop. I'll also grind the front faces of the scales using the adjustable table angle. Over to the buffer, buff up the front face a little. Now I could do this later since these are replaceable, but force of habit, I guess. Then I'll grind the scales to shape, profiling them to fit comfortably in the hand. Next, we'll slap them on the blade and grind everything to shape. Basically, this is a 3-stage process. I rough grind the first set. Then I rough grind and finish grind the second set. In other words, I'm going up to higher grits and really just kind of making everything look nice, getting all my curves correct and so on. Then I'll go back and very carefully, removing the absolute minimum amount of material, finish grind the first set. The reason for doing it this way, coming back to that first set a second time, is that both sets are going to have to fit as closely as possible to the tang. You know, if you just blast away on the first set, then blast away on the second set, you'll end up getting down to metal. You'll reduce the size of the tang a good bit, and that first set is then going to end up oversized and won't fit quite right. By doing it in this sequence and taking off minimal amount on the second pass of the first set, you can pretty much nail both sets. And that's how it worked here. Just feeling it, you'd never even know which one I did first. They both fit perfectly. And once that's done, I'll hit them up on the buffer to bring out the details in the crosscut micarta. Now I'll screw everything back together. Very simple and easy to do. And this is kind of the payoff of this whole approach, is that once you've done all this preliminary drilling, everything else super easy. Thanks for watching, guys. If you like what we're doing here, please subscribe and make sure that you click on that bell so you get notified of all the latest videos. Want to buy a knife from me? Check out my modern blades at tacticsarmory.com. Digging the channel? You can support our video making efforts on Patreon. You know, I've been banging away on these videos for like 10 years, so I hope you'll show some love for all that hard work. Link in the cards and descriptions. Finally, if you're interested in making Japanese swords, check out my full line of Japanese sword videos where I show how to forge Japanese swords as well as how to polish them and how to make fittings, handles, and scabbards. WalterSorrellsBlades.com.